NASA has just announced its final decision regarding the fates of the two astronauts aboard the International Space Station, whose original 8-day space jaunt had turned into a nebulous multi-month excursion. Suni Williams and Butch Wilmore, who launched to the ISS aboard Boeing's Starliner capsule on June 5th, will return home no earlier than February of 2025. Furthermore, NASA and Boeing jointly decided that Williams and Wilmore will not head back to Earth aboard the same Starliner capsule that brought them to the ISS. Rather, they will climb aboard a SpaceX Dragon capsule for their descent to our planet, a vessel dedicated to the Crew 9 mission set to launch in September that will be modified to accommodate the Starliner astronauts. That capsule will only launch with 2 crew members in order to create space for Wilmore and Williams when the time comes to return to Earth, and it will also be reconfigured to carry more cargo, personal items, and Dragon-specific spacesuits for the Starliner duo. Meanwhile, NASA and Boeing are going to work on bringing the Starliner capsule back to Earth, crewless, to land in White Sands Space Harbor, New Mexico, sometime in September. This decision comes after quite a bit of uncertainty about when the 2 Starliner astronauts will come back to Earth, following the completion of what's known as the crew flight test of their capsule. The test is named as such because this trip marked the first time Starliner embarked on a crewed mission, in contrast to its previous 2 uncrewed tests. Safety is of concern because of what the team says is a key issue with Starliner's propulsion system, namely, its thrusters. Starliner's launch to orbit wasn't exactly perfect, having been delayed due to a minor helium leak, for instance, but its docking to the ISS was what most worried operators. Basically, during docking, the capsule experienced malfunctions in 5 of its 28 reaction control thrusters. Both NASA and Boeing therefore decided to extend the Starliner astronauts' stay aboard the ISS while they troubleshooted the complication, and it would appear that a solution hasn't yet been defined. According to NASA's Commercial Crew Program Manager Steve Stick, we are dealing with a very complex issue with the thrusters. It's challenging to predict their performance. It's challenging to predict the temperatures we'll see. So, because of all that uncertainty, NASA Administrator Bill Nelson emphasized during Saturday's conference that it's too risky to attempt bringing Wilmore and Williams back to the planet within the Starliner capsule that ferried them off. Of note, Nelson mentioned that NASA's 2 fatal space shuttle accidents, Challenger in 1986 and Columbia in 2003, that killed 14 astronauts collectively, were on his mind when participating in the decision-making process, particularly as he was a U.S. Senator during the latter. For those who don't know, on January 28, 1986, the Space Shuttle Challenger broke apart 73 seconds after liftoff, killing all 7 crew members aboard. The disaster shocked the nation and the world as it was broadcast live on television. Among the crew was Krista McAuliffe, a schoolteacher selected to be the first civilian in space, which heightened the public interest in the mission. The immediate cause of the Challenger disaster was the failure of an O-ring seal in its right solid rocket booster. The O-rings were designed to prevent hot gases from escaping the boosters, but the unusually cold temperatures on the day of the launch compromised the integrity of the rubber material. When the O-ring failed, hot gases escaped, leading to the destruction of the external fuel tank and the disintegration of the shuttle. But the fact is that the disaster could have been prevented. Engineers at Morton Thiokol, the contractor responsible for the solid rocket boosters, had expressed concerns about the O-ring's performance in low temperatures. However, NASA officials, under pressure to maintain the shuttle's launch schedule, decided to proceed with the launch. The Rogers Commission, formed to investigate the disaster, criticized NASA's management and decision-making processes, highlighting a culture that prioritized schedule over safety. The Challenger disaster led to a 32-month hiatus in the Space Shuttle program and significant changes in NASA's approach to safety and risk management. The tragedy also profoundly impacted the American public's perception of space exploration, reminding the world of the high stakes involved in pushing the boundaries of human achievement. Another accident happened on February 1, 2003, when the Space Shuttle Columbia disintegrated upon re-entry into Earth's atmosphere, killing all 7 astronauts on board. The crew had just completed a successful 16-day scientific mission in orbit, making the loss even more heartbreaking. The cause of the Columbia disaster was damage to the shuttle's thermal protection system, which occurred during launch. A piece of foam insulation broke off from the external fuel tank and struck the left wing of the shuttle, creating a hole in the heat-resistant tiles that protected the shuttle from the extreme heat of re-entry. During re-entry, superheated air entered the wing, leading to the destruction of the shuttle. The investigation into the Columbia disaster revealed that NASA had been aware of the foam shedding problem for years, but the risk had been deemed acceptable. In the days following the shuttle's launch, engineers detected the foam strike but were unable to definitively determine the extent of the damage. Despite requests from some engineers to inspect the damage using space-based assets, NASA management decided against it, assuming that nothing could be done even if the damage was severe. So far, it could be said that the Challenger and Columbia disasters were defining moments in NASA's history, leading to profound changes in how the agency approaches spaceflight safety. These 2 accidents serve as solemn reminders of the risks involved in space exploration. They underscore the need for vigilance, transparency, and a culture that values safety over schedule. While the loss of the Challenger and Columbia crews is a permanent scar on NASA's legacy, the lessons learned continue to guide the future of human spaceflight. As Nielsen said, NASA, ever since, has tried very hard to bring about an atmosphere in which people are encouraged to step forward and speak their mind, and I think right today is a good example of that. On a more positive note, NASA's Associate Administrator Jim Free said that NASA and the Boeing team have made substantial technical progress in building a new and more accurate thruster model based on physical thruster testing, as well as an understanding of relevant fluid physics and material properties. Of course, the choice to keep Wilmore and Williams on the ISS until February 2025 means they'll have to remain on the Earth-orbiting station for an unanticipated total of about 8 months, which raises questions about how the delay affects station operations. However, ISS Program Manager Dana Weigel doesn't feel any major stress about the amended duration, saying the agency has had astronauts stay on the station for about 12 months at a time before. Plus, in terms of supply allocation, all astronauts currently aboard the station have been fine, and there hasn't been a need to ration, she explained. So, next steps? Well, they involve planning for the uncrewed Starliner capsule's descent to Earth, which would technically be referred to as an uncrewed test flight. And according to the latest update, Boeing's Starliner capsule now has a homecoming date. NASA announced most recently that Starliner will depart the International Space Station no earlier than next Friday, provided the weather cooperates and no technical issues pop up. If all goes according to plan, the capsule will undock at 6:04 p.m. EDT on September 6 and land under parachutes 6 hours later in White Sands Space Harbor in New Mexico. With this plan, it is clear that NASA and Boeing are changing the separation sequence that they planned, and they will review those aspects at the readiness review. They are going to go with a simplified separation technique to get away from the station a little more quickly. We'll get to the deorbit burn and execute that nominally. When asked about where Boeing stands on all of this, Ken Bowersox, NASA's Associate Administrator for Space Operations, says the polling was unanimous amongst all the NASA folks, but that Boeing officials expressed they'd be willing to bring a crew home on Starliner. They believe in their vehicle. As far as the mood, all of them really wanted to complete the test flight with crew, and I think, unanimously, were disappointed not to be able to do that. There was also talk about the importance of supporting Boeing in its endeavor to find success with Starliner in general, especially because NASA hopes to have more than one option for crew flights in the future. Right now, SpaceX's capsule is the go-to, but competition is essential in many ways. It causes you to develop your technology, it causes you to get better pricing, and the agency would like to have that competition in the future. This is in fact why, in 2014, NASA awarded Boeing a $4.2 billion contract to build a capsule that sees 6 crewed flights to the ISS. SpaceX received a similar $2.6 billion contract that year and has since completed 9 such flights in its Dragon capsule. Crew 9 would mark the 10th. To that end, Nelson also affirms he is 100% certain that Boeing will launch Starliner with a crew on board again, but not before completing all necessary safety testing. NASA wants to further understand the root causes and understand the design improvements so that the Boeing Starliner will serve as an important part of our assured crew access to the ISS. As Bill Nelson emphasized, our core value is safety, and it is our North Star. So, after all, the decision that Boeing Starliner astronauts will return home on a SpaceX Dragon in 2025 has not been easy, but it is absolutely the right one. Regardless, obviously the decision has brought workers at Boeing to a crossroads, with some of them saying they are humiliated, embarrassed, and horrified. One Boeing employee told the Post in a report that they have had so many embarrassments lately, we're under a microscope. This just made it like 100 times worse. Additionally, they said they hate SpaceX and talk shut about them all the time, only to realize that now they're bailing us out. And while Boeing's morale is in the toilet after NASA chose SpaceX, SpaceX founder Elon Musk also commented on the decision. He wrote via X that, arguably, a natural turn of events. Just as the car companies did not dominate the medium of air, they tried. The aircraft companies will not dominate the medium of space. In another tweet, Elon Musk once again the importance of Starship in his ultimate goal of making multiplanetary life a possibility, just a couple of hours after NASA's announcement. The idea of Starship began as a part of SpaceX's broader mission to make space travel more affordable and accessible. SpaceX had already made significant strides with the Falcon series rockets, which were partially reusable. However, SpaceX's CEO Elon Musk envisioned a spacecraft that could be fully reused, dramatically reducing the cost of each launch. This vision materialized into the Starship, initially referred to as the BFR for Big Falcon rocket, a name that reflected the sheer scale and ambition of the project. The Starship is designed to be a 2-stage system, consisting of the Starship spacecraft itself and the Super Heavy rocket booster. The spacecraft is designed to carry both crew and cargo, while the Super Heavy booster provides the necessary thrust to escape Earth's gravity. Both components are fully reusable, a feature that Musk believes is crucial for making space travel economically viable. The spacecraft stands at 50 meters tall with a diameter of 9 meters and is capable of carrying over 100 tons of cargo or 100 passengers at a time. Starship's design is a marvel of engineering, incorporating advanced materials and cutting-edge technology. The spacecraft is built primarily from stainless steel, a choice driven by its strength, durability, and resistance to the extreme temperatures encountered during space travel. Stainless steel also becomes stronger at cryogenic temperatures, which is beneficial when dealing with the supercooled fuels used by the spacecraft. One of the most innovative aspects of Starship is its Raptor engines, which are powered by a combination of liquid methane and liquid oxygen, methalox. This choice of fuel is significant because methane can be produced on Mars using a process called the Sabatier reaction, which combines carbon dioxide from the Martian atmosphere with hydrogen. This means that Starship could potentially refuel on Mars, making return trips to Earth more feasible. The spacecraft also features a heat shield made of ceramic tiles that protect it during re-entry into Earth's atmosphere. The design is intended to be lightweight and reusable, minimizing the need for repairs between missions. Additionally, Starship is equipped with large flaps that help control its descent, allowing it to perform a controlled landing, similar to SpaceX's Falcon 9 rockets. Elon Musk's plan for Mars is nothing short of extraordinary. He envisions a future where humans are a multiplanetary species, with a self-sustaining colony on Mars as a critical step in ensuring the long-term survival of humanity. According to Musk, having a backup plan for humanity is essential, given the various existential threats that could potentially wipe out life on Earth, such as asteroid impacts, nuclear war, or runaway climate change. To achieve this vision, SpaceX plans to use Starship to ferry people and cargo to Mars. The journey to Mars is fraught with challenges, including the vast distance, the harsh environment, and the psychological effects of long-duration space travel. However, Musk is confident that these challenges can be overcome with the right technology and planning. The timeline for Musk's Mars plan is ambitious. He has stated that he hopes to send the first crewed mission to Mars as early as the mid-2020s, with the ultimate goal of building a city on Mars by 2050. The city would need to be self-sustaining, capable of producing its own food, water, and energy, as well as housing a population of up to 1 million people. Of course, before reaching Mars, Starship must undergo rigorous testing and development. SpaceX has already made significant progress, with multiple prototypes of Starship having been built and tested. These tests have included high-altitude flights, where Starship ascends to tens of kilometers above Earth, performs a complex set of maneuvers, and then attempts a controlled landing. While some tests have ended in failure, with prototypes exploding upon landing, each test provides valuable data that SpaceX uses to improve the design. The iterative approach, where prototypes are rapidly built, tested, and refined, is a hallmark of SpaceX's development process and has been instrumental in the company's previous successes. In addition to testing Starship itself, SpaceX is also developing the Super Heavy booster, which will provide the necessary thrust to get Starship into orbit. The booster is expected to be equipped with up to 33 Raptor engines, making it one of the most powerful rockets ever built. The combination of Starship and Super Heavy will be capable of carrying out a wide range of missions, from deploying satellites to delivering cargo to the Moon and Mars. Thus, regardless of the challenges, Starship represents a transformative step forward in space exploration. The technology developed for Starship has the potential to revolutionize not just space travel, but also space science. One of the most significant ways Starship could supercharge space science is through its unmatched payload capacity. Traditional rockets have been constrained by limited payload space and weight, forcing scientists to make compromises on the size, scope, and capabilities of their instruments. For instance, the Hubble Space Telescope, while revolutionary, was limited by the payload capacity of the Space Shuttle. The James Webb Space Telescope, designed to look further into the universe's past, has been in development for over 2 decades, in part because of the extreme precision required to fit its components into the payload bay of the Ariane 5 rocket. Starship changes this equation entirely. With a payload capacity of up to 100 tons to low Earth orbit and the potential to carry significant mass to higher orbits and deep space destinations, Starship allows scientists to think big, really big. Telescopes could be orders of magnitude larger than anything previously launched, allowing for far greater resolution and sensitivity. Space probes could carry more sophisticated instruments, larger power supplies, and greater fuel reserves, extending their operational lifespans and increasing the range of their missions. In essence, Starship's payload capacity opens up a new era of big science in space. Another transformative aspect of Starship is its potential to drastically reduce the cost of space exploration. Historically, space missions have been astronomically expensive, with costs often running into the billions of dollars. A significant portion of these costs is associated with the launch itself, where even the smallest missions can run into tens or hundreds of millions of dollars. SpaceX's Starship, with its fully reusable design, aims to break this cost barrier. The reusability of Starship is akin to the revolution brought about by commercial aviation. Just as airplanes can be used for multiple flights, drastically lowering the cost of air travel, a reusable spacecraft can make space missions more affordable. SpaceX has already demonstrated this with its Falcon 9 rockets, where reusability has brought down the cost of launches. Starship takes this a step further, with the goal of reducing launch costs to as low as $2 million per flight. For space science, this reduction in cost could be revolutionary. Scientists and space agencies would no longer be forced to choose between missions due to budget constraints. Instead, they could embark on a broader array of missions simultaneously. More frequent and affordable launches could enable continuous, real-time data collection, more dynamic mission planning, and the ability to adapt and respond to new scientific discoveries as they happen. Starship's ability to carry humans to the Moon, Mars, and beyond is perhaps its most talked-about feature, but it's not just about human exploration, it's about science. By enabling human presence on other celestial bodies, Starship could catalyze a new era of space science conducted on the surfaces of the Moon and Mars. For example, on the Moon, humans could set up sophisticated research stations equipped with advanced laboratories, telescopes, and other scientific instruments. Unlike robotic missions, which are limited by pre-programmed instructions and the lag time in communication between Earth and the Moon, humans can conduct research in real time, make decisions on the fly, and adapt to unexpected challenges. The potential for scientific discovery on the Moon is vast, from studying its geology and history to setting up observatories that could take advantage of the Moon's lack of atmosphere to observe the universe in wavelengths that are difficult or impossible to study from Earth. Mars, often dubbed the next frontier, holds even greater potential. Starship could facilitate the establishment of a permanent research outpost on Mars, where scientists could study the planet's geology, climate, and potential for past or present life. The search for life on Mars is one of the most compelling scientific questions of our time, and having humans on the ground would greatly enhance our ability to explore this question. The ability to conduct fieldwork, analyze samples in situ, and adapt research strategies in real time would bring a level of scientific rigor and flexibility that is impossible with robotic missions alone. Beyond the Moon and Mars, Starship's capabilities could extend our reach to the outer planets and their moons, which are some of the most intriguing targets for space science. For example, Jupiter's moon Europa is believed to have a subsurface ocean beneath its icy crust, making it one of the prime candidates in the search for extraterrestrial life. A mission to Europa or similar moons, like Saturn's Enceladus, would require a spacecraft capable of carrying a large suite of instruments, drilling equipment, and potentially even a lander or submersible to explore these alien oceans. Starship could make such missions feasible, allowing scientists to design more ambitious and capable probes. Furthermore, the spacecraft's ability to carry large amounts of fuel could enable more complex missions involving multiple stages, such as orbiters that deploy landers or submersibles to study these moons in detail. The ability to conduct in-depth, multi-phase exploration of the outer planets and their moons would significantly advance our understanding of the solar system and the potential for life beyond Earth. And not stop there, in some aspects, Musk's Mars rocket even could revolutionize space-based astronomy. Space-based astronomy has already transformed our understanding of the universe, with telescopes like Hubble and missions like Kepler and Spitzer providing unprecedented insights into the cosmos. However, these telescopes have been limited by the constraints of current launch systems. Starship's payload capacity and cost-effectiveness could revolutionize space-based astronomy, enabling the construction of telescopes that are orders of magnitude larger and more powerful than anything currently in operation. Imagine a space telescope with a mirror larger than 20 meters in diameter, capable of capturing images of distant galaxies with unparalleled resolution, or an array of smaller telescopes that could be deployed in different orbits around the Earth or even on the far side of the Moon, free from the interference of Earth's radio waves. Such an observatory could peer deeper into the universe's history, searching for the first stars and galaxies that formed after the Big Bang, or it could focus on the study of exoplanets, analyzing their atmospheres for signs of life with unprecedented precision. Moreover, Starship could enable the deployment of multiple telescopes or other scientific instruments simultaneously, creating a network of observatories that work in concert to study the universe in different wavelengths or from different vantage points. This kind of multifaceted approach would provide a more comprehensive understanding of the cosmos, allowing scientists to cross-reference data and build a more detailed picture of the universe's structure and evolution. What's more, somehow SpaceX's flagship rocket also could support the aging International Space Station. While the International Space Station, or ISS, has been a cornerstone of space science for over 2 decades, its days are numbered, with plans for its decommissioning likely within the next decade. Starship could play a crucial role in supporting the ISS during its remaining years and in helping to develop the next generation of space stations. With its ability to carry large payloads, Starship could deliver significant amounts of supplies, equipment, and even new modules to the ISS, extending its operational life and enhancing its scientific capabilities. Beyond the ISS, Starship could facilitate the construction of new space stations, whether in low Earth orbit, lunar orbit, or even in deep space. These stations could serve as hubs for scientific research, manufacturing, and exploration, enabling long-term human presence in space and the continuous advancement of space science. While much of the focus on Starship is on its potential for deep space exploration, it could also have significant implications for Earth science. By providing a low-cost, high-capacity platform for launching satellites and other instruments into orbit, Starship could revolutionize the way we monitor and study our own planet. For example, Starship could deploy large constellations of Earth-observing satellites that provide real-time data on climate change, natural disasters, and other environmental phenomena. These satellites could offer higher resolution and greater coverage than current systems, enabling more accurate and timely predictions of events like hurricanes, wildfires, and earthquakes. Such data would be invaluable for scientists, policymakers, and emergency responders, helping to mitigate the impacts of these events and protect lives and property. Moreover, Starship could enable the deployment of more advanced instruments for studying Earth's atmosphere, oceans, and land masses, providing new insights into the complex systems that drive our planet's climate and ecosystems. This data would be critical for understanding and addressing the challenges of climate change, biodiversity loss, and other pressing environmental issues. In short, SpaceX's Starship represents a quantum leap in our ability to explore and understand the universe. Its unprecedented payload capacity, cost-effectiveness, and versatility could transform space science in ways that are only just beginning to be imagined. From enabling larger and more ambitious space missions to lowering the cost of exploration and expanding our reach to new destinations, Starship has the potential to supercharge space science and usher in a new era of discovery. As we stand on the cusp of this new era, the possibilities seem limitless. With Starship, we could unlock the mysteries of the Moon and Mars, explore the outer planets and their moons, revolutionize space-based astronomy, and even enhance our understanding of Earth itself. The future of space science is bright, and Starship could be the vehicle that takes us there. But as told, while Mars and beyond is the ultimate goal, the journey begins with the Moon, a destination that holds immense scientific, strategic, and cultural importance. SpaceX's involvement in lunar exploration became official when NASA selected Starship as the human landing system for the Artemis program. Artemis aims to land the first woman and the next man on the Moon, with a focus on exploring the lunar South Pole, a region rich in resources like water ice. Starship was chosen for its capability to deliver a significant payload to the lunar surface, as well as its potential for future missions. The version of Starship designated for the Artemis program will be modified to meet NASA's specific requirements. These modifications include the addition of landing legs for a stable touchdown on the lunar surface, a spacious crew cabin to accommodate astronauts, and enhanced life support systems to ensure the crew's safety during their mission. Additionally, Starship's powerful Raptor engines will allow it to perform precision landings, even in challenging lunar environments. Put simply, Starship's involvement in the Artemis program is a major step towards establishing a sustainable human presence on the Moon. On the other hand, note that even the Artemis mission architecture itself involves multiple steps. First, NASA's SLS rocket will launch the Orion spacecraft, carrying astronauts to lunar orbit. Starship will then rendezvous with Orion, transferring the crew to its spacious interior. From there, Starship will descend to the lunar surface, where astronauts will conduct a week-long mission before returning to Orion for the journey back to Earth. This mission profile demonstrates not only the technical prowess of Starship, but also its role as a critical component of NASA's lunar exploration strategy. Most likely, SpaceX's Starship is not just a means of returning to the Moon. It's a platform for the future of lunar exploration. Once Starship proves its capability with the initial Artemis missions, the possibilities for its use on the Moon are vast. One potential application is the construction of a lunar base, which could serve as a permanent outpost for scientific research and commercial activities. Such a base could be used to study the Moon's geology, search for resources, and develop technologies needed for long-term human survival in space. Moreover, the Moon could become a hub for space tourism, with Starship offering a means for private citizens to experience the lunar surface. SpaceX has already announced plans for private lunar missions, including a circumlunar flight with a crew of artists and cultural figures. These missions could pave the way for a new era of space exploration, where the Moon is accessible not just to astronauts, but to anyone with the desire and means to travel there. Starship's success on the Moon will also be a stepping stone to Mars. The technologies and operational experience gained from lunar missions will inform the development of Mars-specific systems, such as habitats, life support, and surface operations. By first establishing a foothold on the Moon, SpaceX can test these systems in a relatively close and accessible environment before deploying them on Mars, where the challenges are even greater. In short, SpaceX's Starship represents the dawn of a new era in space exploration. With its innovative design, unprecedented capabilities, and ambitious goals, Starship is poised to take humanity back to the Moon and beyond. The return to the Moon is not just about revisiting old achievements. It's about laying the groundwork for a future where humans are a spacefaring species. Through the Artemis program and beyond, Starship will play a pivotal role in transforming this vision into reality, heralding a future where the Moon is not just a distant orb in the night sky, but a world where humans live, work, and thrive. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.